The Great Pyramid of Giza stands as a monument not only to its builders but also to a profound and enduring mystery. For centuries, we have been told it was a tomb, a grand resting place for a pharaoh. Yet, this explanation feels incomplete, almost too simple for a structure of such staggering complexity and precision. When we look past the conventional story, we find a building filled with features that defy easy classification. The internal layout, with its ascending and descending passages, its grand gallery, and its precisely engineered chambers, suggests a purpose far more sophisticated than mere burial. The pyramid asks us questions, and the traditional answers often fall short of satisfying our engineering curiosity. The very construction of the pyramid challenges our understanding of ancient capabilities. Millions of massive stone blocks, some weighing as much as 80 tons, were quarried and transported over great distances. They were then assembled with a level of accuracy that would be difficult to replicate even with today's advanced technology. The joints between the casing stones, now mostly gone, were so fine that a razor blade could not be inserted between them. This wasn't just good craftsmanship, it was an obsession with precision. This level of care hints at a functional requirement, where every surface and every angle had to be perfect for the entire system to work as intended. It compels us to ask, what was that function? Inside, the mystery only deepens. The so-called king's and queen's chambers are stark, undecorated, and devoid of the hieroglyphs and artifacts we find in other Egyptian tombs. There is no grand sarcophagus in the king's chamber, only a lidless granite box, too large to have been brought in through the passageways. This coffer shows signs of having been cut with high-speed tools, leaving behind evidence of a technology we do not associate with the Bronze Age. These anomalies push us to consider alternative possibilities. Perhaps the pyramid was not a passive structure, but an active one. Perhaps it was a machine. This essay will explore one such possibility, the theory that the Great Pyramid was a highly advanced power plant. We will examine the evidence embedded within its very stones, from the unique materials used in its construction to the incredible acoustic properties of its chambers. We will look at the structure not as a tomb for a dead king, but as a functioning piece of machinery designed for a specific, energetic purpose. By viewing the pyramid through the lens of a modern engineer, we can begin to decode its secrets and appreciate the genius of its creators in a completely new light, questioning everything we thought we knew about the ancient world. At the very core of the Great Pyramid lies the King's Chamber, a room that holds the key to understanding the structure's potential function. This chamber is unique, not just for its location, but for the material from which it is constructed. Unlike the rest of the pyramid's core, which is made primarily of limestone, the King's Chamber is built entirely from massive blocks of red Aswan granite. This choice of material was clearly deliberate and significant. Aswan granite had to be transported over 500 miles from the south, a monumental task that would only have been undertaken for a very specific reason. The builders went to extraordinary lengths to use this particular stone in this particular room. The granite itself is a fascinating material. It is an igneous rock, formed from cooled magma, and is known for its incredible hardness and durability. But it has another important property. It is rich in quartz crystals. Aswan granite contains a very high concentration of these crystals, making up over half of its composition. Quartz is not just a pretty mineral. It has unique electrical properties that are fundamental to modern technology. When we see such a specific and difficult-to-obtain material used in the most critical part of the structure, we must ask why. The answer may lie not in the granite's strength, but in its energetic potential. The construction of the chamber is a marvel of precision engineering. The granite blocks are cut and fitted with astonishing accuracy, creating flat surfaces and perfectly square corners. The entire room is a masterpiece of stonework, but it is completely bare. There are no inscriptions, no paintings, and no signs that it was ever intended for ceremonial burial. Its stark, functional appearance is more reminiscent of an industrial setting than a royal tomb. It feels like the power-generating core of a machine, where aesthetics are secondary to performance. The room was designed for a purpose, and that purpose appears to be physical and energetic, not spiritual. The granite coffer within the chamber is another piece of the puzzle. It is often called a sarcophagus, but it shares few characteristics with other Egyptian coffins. It is undecorated, lidless, and shows evidence of advanced machining techniques. Its dimensions and placement within the chamber seem deliberate and purposeful. If the king's chamber was the heart of a power plant, this coffer could have been a critical component, perhaps a resonator or a transducer, designed to interact with the energy generated within the room. Every element, from the stone on the walls to the box in the center, points toward a functional mechanical design. To understand how the Great Pyramid could have functioned as a power plant, we must first explore a remarkable property of quartz crystals known as the piezoelectric effect. The term may sound complex, but the concept is quite simple. In essence, when you apply physical pressure to a quartz crystal, by squeezing it, vibrating it, or striking it, you generate a small but measurable electric voltage across its surface. This phenomenon works in reverse as well. If you apply an electric voltage to a quartz crystal, it will vibrate at a very precise frequency. This two-way conversion between mechanical energy and electrical energy is the foundation of countless modern devices. You interact with the piezoelectric effect every day, likely without realizing it. It is the principle behind the quartz crystal in your watch, which vibrates at an exact frequency to keep perfect time. It is used in the igniter of a gas grill, where pressing a button strikes a crystal to create a spark. Microphones, speakers, and sonar equipment all rely on this incredible property of quartz to convert sound waves into electrical signals and back again. It is a fundamental principle of modern electronics and energy conversion. The ancient builders of the pyramid, by choosing granite rich in quartz, may have been tapping into this very same principle. Imagine the king's chamber, constructed from tons of granite containing over 50% quartz. Now imagine this entire chamber being subjected to immense rhythmic pressure or vibration. The countless quartz crystals embedded within the granite walls, floor, and ceiling would all be stressed simultaneously. Each crystal would produce a small electrical charge in response to this mechanical stress. When multiplied by the sheer volume of quartz in the chamber, the cumulative effect could be significant. The entire room could have been designed to act as a massive piezoelectric generator, converting mechanical vibrations into electrical energy on a grand scale. This theory provides a compelling reason for the builder's specific choice of Aswan granite. It was not chosen just for its beauty or strength, but for its active, energetic properties. The king's chamber was not simply a container, it was a transducer. It was designed to convert energy from one form to another. The vibrations that powered this system would need to come from somewhere, and the pyramid's overall design suggests that it was engineered to collect and channel subtle vibrations from the earth itself, focusing them on this central chamber to initiate the piezoelectric process. The pyramid, in this view, becomes a machine for harvesting terrestrial energy. Above the flat ceiling of the king's chamber lies one of the most astonishing and mysterious features of the Great Pyramid, a series of 5 separate compartments, often called relieving chambers. These compartments are formed by massive granite beams, stacked one on top of the other, with small gaps in between. The conventional explanation is that these beams were designed to relieve the pressure from the immense weight of the pyramid's core masonry, protecting the ceiling of the king's chamber from collapsing. This structural explanation seems logical at first glance, but a closer look reveals details that challenge this simple interpretation. The granite beams themselves are monumental feats of engineering. Each one weighs between 50 and 80 tons, and they were quarried, transported, and lifted to a height of over 200 feet with incredible precision. If their only purpose was to provide structural support, one must wonder why such a complex, multi-layered design was necessary. A single, solid layer or a simple angled roof could have accomplished the same goal with far less effort. The decision to create 5 distinct layers of separated beams suggests a more sophisticated purpose. It points toward a design that was concerned with more than just static weight distribution. Furthermore, the preparation of these beams is meticulous. The top surfaces of the beams in the lower chambers were left rough and unfinished, but the bottom surfaces, the ceilings of each compartment, were polished to a smooth finish. Why would the builders take the time and effort to polish surfaces that were never meant to be seen, hidden deep within the pyramid structure? This detail is inconsistent with a purely structural function. Polished surfaces are excellent at reflecting energy, particularly sound waves. This suggests that these chambers were designed with acoustic properties in mind, intended to interact with and amplify vibrations moving through the pyramid. The separation between the layers of beams is also crucial. These gaps would allow each set of beams to vibrate independently, responding to specific frequencies like the strings of a musical instrument. The entire complex could have acted as a series of resonant chambers, designed to tune and amplify the vibrations channeled up from the base of the pyramid. Rather than simply relieving pressure, these chambers may have been actively generating it, in the form of powerful, focused acoustic energy. This energy would then be directed downward onto the king's chamber, providing the necessary mechanical stress to activate the piezoelectric properties of the granite below. One of the most compelling pieces of evidence for the power plant theory lies in the treatment of the granite beams in the relieving chambers. As engineers and craftsmen, we understand that you typically focus your efforts on the parts of a structure that are visible or critical to its function. You would not, for instance, spend weeks polishing the inside of a water pipe that will be buried underground. Yet, in the Great Pyramid, we find that the builders applied the same high level of precision and finish to surfaces that were sealed away, destined never to be seen by human eyes again. This is a profound clue to their true purpose. The bottom surfaces of the granite beams forming the ceilings of these hidden chambers were polished smooth. In contrast, the top surfaces of the same beams, which form the floors, were left rough and uneven. If the goal was purely structural, this makes no sense. In fact, rough surfaces would provide better friction and stability. The decision to polish the ceilings points directly to an acoustic function. A smooth, polished surface is an excellent reflector of sound waves. It ensures that acoustic energy is bounced back with minimal loss, maintaining its intensity. These hidden surfaces were finished with the care of a musical instrument maker. This meticulous finishing of unseen parts is not an isolated quirk. It is a pattern seen throughout the pyramid. The level of precision is not reserved for the main chambers, but is present in passageways and internal structures that were sealed off. This suggests that every surface had a functional role to play in the operation of the machine. The pyramid was not a building in the conventional sense. It was an integrated system. The polished surfaces were not for decoration, they were for performance. They were designed to manage and direct the flow of energy through the structure with maximum efficiency. Consider the implications of this. The builders were not simply stacking blocks to create a tomb. They were creating a resonant cavity, a massive acoustic device. Each chamber, with its polished ceiling, was designed to reflect and focus sound energy downward. The entire stack of relieving chambers could have functioned as a granite tuning fork, vibrating in sympathy with the Earth's natural hum. The care taken with these hidden beams is strong evidence that their purpose was far more advanced than simple structural support. They were integral components of a dynamic, energy-converting machine. The concept of resonance is key to understanding the Great Pyramid as a machine. Resonance occurs when an object is vibrated at its natural frequency, causing it to vibrate with much greater amplitude. Think of it like pushing a child on a swing. If you time your pushes to match the swing's natural rhythm, even a small push can create a very large swing. The Great Pyramid appears to have been designed as a massive resonant system, built to capture and amplify the natural low-frequency vibrations of the Earth itself. The entire structure was, in effect, a giant antenna and amplifier for terrestrial energy. The Earth constantly vibrates with a low-frequency hum, a phenomenon known as the Schumann resonance. This background energy is always present, permeating our planet. The Great Pyramid, with its specific dimensions and materials, seems perfectly designed to couple with this energy. It would act as an inverted pendulum, swaying almost imperceptibly in response to these terrestrial vibrations. The pyramid's design, including the Grand Gallery, would then collect and amplify this energy, channeling it upward toward the king's chamber. The Grand Gallery, with its corbelled walls and series of slots, looks very much like a giant resonant cavity. The slots along the walls of the Grand Gallery may have once held a series of resonators, perhaps made of wood or metal, which would have been precisely tuned to vibrate at specific frequencies. As the energy from the Earth moved up through the pyramid, these resonators would begin to vibrate powerfully, converting the low-frequency rumble into a complex and intense acoustic field. The sound would have been deafening, a powerful hum that filled the entire gallery. This acoustic energy would then be focused and directed up the final passageway and into the king's chamber, the heart of the power plant. This is where the granite beams above the king's chamber come into play. They would not just be passively vibrating. They would be actively driven by the intense sound from the Grand Gallery. The entire complex of beams, like a stack of massive tuning forks, would resonate in sympathy, creating immense and rhythmic pressure waves. This is the mechanical stress needed to power the piezoelectric generator below. The pyramid was not just built on a solid foundation, it was acoustically coupled to the planet, designed to turn the subtle hum of the Earth into a powerful source of industrial-scale energy. When we analyze the Great Pyramid as a machine, we find stunning parallels to modern technology. The internal components and their proposed functions are not mystical or magical. They're based on sound principles of physics and engineering that we use every single day. The King's Chamber, with its quartz-rich granite, functions as a piezoelectric transducer, a device we use in microphones and sensors. The idea of converting mechanical vibration into electricity is not science fiction. It's actually the basis for a significant portion of our electronic world. The pyramid appears to be using this principle on a monumental scale. The Grand Gallery, with its proposed series of resonators, acts very much like a modern acoustic amplifier or a waveguide. Waveguides are structures used in high-frequency electronics like radar systems to guide and direct energy waves with minimal loss. The shape and design of the Grand Gallery, with its highly reflective walls and angled ceiling, is perfectly suited for this purpose. It seems engineered to collect, filter, and amplify acoustic energy, focusing it with great intensity toward its target, the King's Chamber. It's a piece of acoustic technology that we can recognize and understand from a modern engineering perspective. Furthermore, the concept of harvesting ambient energy from the environment is a major goal of modern green technology. We build solar panels to capture energy from the sun and wind turbines to capture energy from the wind. The Giza power plant theory proposes that the ancient Egyptians were doing something similar, but they were harvesting geothermal and seismic energy from the Earth itself. They built a machine that was tuned to the planet's natural frequency, a passive energy collector that converted subtle vibrations into usable power. This is a concept that cutting-edge scientists are exploring today. Even the so-called air shafts leading from the King's and Queen's chambers find a parallel in modern technology. In a power plant, you need inputs and outputs. These shafts, which do not point to any known stars with significant accuracy for alignment, may have served as conduits. One shaft could have brought in a chemical catalyst like hydrated zinc, while another could have channeled the resulting depleted hydrogen gas out of the chamber. This completes the picture of an industrial process, where raw energy is converted, used, and waste products are expelled. The pyramid's design echoes our own technology, separated only by time and scale. Every detail of the Great Pyramid's interior seems to scream function over form. In a tomb or a temple, we expect to see decorations, religious texts, and artistic flourishes that celebrate a king or a god. The pyramid has none of these. Its internal spaces are stark, utilitarian, and geometrically perfect. The walls are bare, the chambers are empty, and the overall feeling is that of an industrial facility, not a sacred space. This lack of ornamentation is not a sign of incompletion, it's a sign of purpose. The beauty of the pyramid is not in its art, but in its engineering. The choice of materials at different points in the structure reinforces this idea. The builders used limestone for the bulk of the core, a relatively soft and easy-to-work material. But for the critical components, the King's Chamber, the coffer, the relieving beams, and the casing stones, they chose much harder and more difficult materials like granite and basalt. This is exactly what a modern engineer would do. You use standard materials for the chassis or frame, but you use specialized high-performance materials for the engine and critical moving parts. The pyramid's construction follows a logic of mechanical design, not architectural or ceremonial design. Consider the immense effort invested in achieving unparalleled precision. The blocks are fitted together so tightly that you cannot see the joints. The main chambers are perfectly level and square. The passages are straight and true over hundreds of feet. This level of accuracy is not necessary for a simple tomb. A building can stand for thousands of years with much lower tolerances. This obsession with precision only makes sense if the pyramid's function depended on it. In a machine, especially a resonant one, every surface and every angle is critical. A slight imperfection could disrupt the energy flow and cause the entire system to fail. Therefore, we must conclude that the pyramid was designed and built to perform a specific task. Its form follows its function. It is a purpose-built piece of equipment. The evidence suggests this function was related to energy conversion. It was designed to harness the vibrations of the Earth, convert them into other forms of energy using acoustic and piezoelectric principles, and then make that power available for use. The Great Pyramid was not a monument to a dead king. It was a living, breathing machine that powered a civilization. We are not looking at a tomb. We are looking at the silent remains of an ancient power station. We are left standing at a crossroads of understanding. Down one path lies the familiar, comfortable story of the Great Pyramid as a pharaoh's tomb, a story that has been told for centuries but leaves countless engineering questions unanswered. Down the other path lies a more radical and challenging idea, the pyramid as a machine, a power plant built with a level of scientific and technical knowledge we never thought the ancients possessed. To accept this theory requires us to fundamentally rethink not just the pyramid, but the entire history of human civilization and technological development. It suggests a lost chapter of our past. The evidence presented, the piezoelectric granite, the acoustic resonance of the chambers, the precision of unseen surfaces, and the parallels with modern technology, builds a compelling case. It transforms the pyramid from a pile of stones into an elegant and sophisticated device. The anomalies that historians struggle to explain as features of a tomb suddenly make perfect sense as components of a machine. The undecorated chambers, the strange coffer, the complex relieving beams, and the mysterious shafts all snap into place as parts of a coherent and functional system. It answers the why behind the builder's incredible efforts. Admittedly, this is a theory. We have not found a user's manual or a schematic diagram carved into the walls. Direct, irrefutable proof remains elusive. However, the physical evidence embedded in the pyramid's construction is undeniable. The stones themselves tell a story of advanced engineering and profound purpose. By applying our knowledge of physics and mechanics, we can read that story and develop a model that fits the evidence far better than the traditional explanation. The power plant theory is not based on fantasy, but on a rigorous analysis of the structure as it exists today. Ultimately, the Great Pyramid challenges us to keep an open mind. It reminds us that our ancestors may have been far more capable than we give them credit for. Perhaps the greatest monument they left behind was not a tribute to death, but a testament to their mastery of life's fundamental energies. Whether it was a tomb or a machine, the Great Pyramid of Giza will continue to inspire awe and curiosity, urging us to look deeper, ask bolder questions, and never assume that we have all the answers. The secret of the pyramid may not be buried with a king, but waiting to be rediscovered in the language of science and engineering.